Alright, so in this video we're going to look at two-way tables and Venn diagrams to model chance process. We're also going to use the general addition rule to calculate probabilities. And first thing I want you to do is look at who owns a home. Okay, so we want to answer these questions. What is the relationship between educational achievement and home ownership? A random sample of 500 U.S. adults was selected. Each member of the sample was identified as a high school graduate or not, and as a homeowner or not. The table displays the data. Suppose we choose a member of the sample at random. Find the probability that the member A is a high school graduate. Okay. B is a high school graduate and owns a home, and C is a high school graduate or owns a home. Okay. So I'll give you a second. You can pause the video and determine those probabilities and then come back. Okay, so is a high school graduate? Well, 221 were high school graduates and homeowners, plus 89, so we had a total of 310 that were a high school graduate. And then we had out of 500, so 310 out of 500. Next, is a high school graduate and owns a home? Well, that was 221 people out of 500 that did both. And finally, is a high school graduate or owns a home? Well, there were 310 high school graduates. Plus there are another 119 that are not high school graduates, but they do own a home, and since it says or, we want to do 310 plus 119 is 429 out of 500. Good. Now, when we talk about how we're going to display this, okay, we have what's called the general addition rule. Which says this: the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Now they will give you this formula on the AP test, however, they will not give it to you in this form. They will use set notation, and it will look like this: A union B. Or the U symbol looks like a U, but it actually stands for union. It means or. It's the same as or. Equals the probability of A plus the probability of B minus the probability of A intersection, now the U is upside down, B. And the and the intersection are the same thing. That's the general addition rule. And we did see that because when you did the probability of A or B, if you really wanted to do that probability of A, so the probability that they're a high school, this one right here, this C. Another way we could do that, the probability that they're a high school graduate, we already did, was 310 out of 500. Plus, the probability they own a home is 340 out of 500. Okay. The problem with using those two numbers is both of those numbers include this 221. 221 is part of the 310, and 221 is part of the 340. So we've double counted that 221. And what we're doing is subtracting off that 221 that we've double counted. That's what this formula does, called the general addition rule. Now, talk about Venn diagrams and how we can make a Venn diagram. Okay. So I'm sure you've seen Venn diagrams before. You might have seen a real simple one. You got just one circle, and this is event A, and out here would be A complement. Everything not A. Okay. Or if we have mutually exclusive events, we might have a circle here. This would be event A, and here would be event B, and they have no overlap. They're mutually exclusive. Now we could have, when most of our Venn diagrams will look something like this, they will have you might have event A and event B, and this is A and B is in the middle. There is A and B with that arrow pointed to it. That's A and B. A or B would be both circles together, and this is not A or B. It's not A or B. It's neither one. It's not A, it's not B. So that would be the rest of the stuff in the sample space there. So let's look at, here's a two-way table summarizing the relationship between educational status and homeownership from the previous example, the one we just used. We're going to do two events. G is being a high school graduate, H is being a homeowner, and we're going to make a Venn diagram. So we go like this. There is overlap, we know that, so we're going to do nice big circle, nice big circle. This is going to be event G, high school graduate, and this is going to be H, a homeowner. Alright. Now in the middle are the 221 people that are both high school graduates and homeowners. In G, they're not a homeowner, but they're a high school graduate. So in here there are 89 people in there that graduated high school but do not own a home. We have 119 people who are not high school graduates but own homes, so that 119 would go here. And then there are 71 people that neither own a home nor are they a high school graduate. That number goes out here in the sample space because it doesn't fit into either circle. So that's what our Venn diagram would look like for this particular application. And the intersection of the two A and B. There's our intersection, A and B, the intersection of the two circles. Inside circle G, but outside circle H. If we go back to here, inside circle G, but outside circle H, that would be this whole thing all the way around here. Let me draw that with a different color, a little thicker. This section that is, the red is G, and then its intersection with H complement, not H. They are G, not H, and that's the second one here. It's the intersection of G and the complement. Now this part within the blue here, that blue, that's H intersection with G complement. So in other words, it's everything that's inside of H that's not in G. Inside of H but not in G. And there's more you can see here. Inside circle H, outside circles, we have that one. And then outside both circles is not G intersected with not H. Where both things are true. Or both, it's not G and it's not H. Okay. So, alright. According to the National Center for Health Statistics, in December 2012, 60% of households had a traditional landline, 89% of households had cell phones, and 51% had both. Suppose we randomly selected a household in December 2012. Okay, so take a minute and pause the video and construct the table, and then you can come back and we'll go through it. Alright, we want to construct our two-way table here. So I'm going to have landline and I'm going to have cell phone. Now it doesn't matter, you could put landline on the rows, and it doesn't matter, either yes or no they have a landline and yes or no they have a cell phone. And then I might have some totals and some totals down here. Okay, so a landline, it said 51% had both. They had a landline and a cell phone, so 0.51 goes there. Now, it says 89% of households had cell phones. So cell phones, yes, that's the total. That's the total number. So 0.89 goes in the total column. 89% of all households had a cell phone. That goes there. And then 60% of households had a traditional landline. So 0.60 goes here. Now we can just use what we know about probabilities to figure this out here. So if the total is 60 and we have 51% said yes, that means that leaves 9% because these two, 51 and 9, have to add up to 60. Same thing here. 51 and 38 also add up, they add up to 89. And so 38% of the population has a cell phone and no landline. And so the last thing, number one, this would have to be, because this has to be 1. Our total has to be 100%. It has to be 1, so this has to be 0.11, so that those two can add up to 89% and 11% make 100%. And then this last little one, there is 0.02. Okay. So let's construct a Venn diagram to match that and go with that. That's part B here. Get our nice little circle here, a nice little circle here, and we're going to call this H, and CH is landline, C is cell. So in our center where they intersect, we know 51%, 0.51, had both. So 0.51 goes in there. In the side of the circle C here, we know that 38% say yes to cell phone and no to landline. So 0.38 goes in there. And for 9% said they had no cell phone but they had landline, so 0.09 goes there. And then lastly, this 2%, they neither had a cell phone nor did they have a landline, so that goes out here, 0.02. There is what our Venn diagram for this particular application looks like. Okay, find the probability that the household had at least one of the two types of phones. At least one. So that would be at least one for C. So if we want to know the probability that they have H or C, well, that's the probability of H plus the probability of C minus the probability of H and C. Well, the probability that they had a landline is 0.6. The probability that they have a cell phone is 0.89. And the probability that they have both is 0.51. So we add those up, we get 0.6 plus 0.89 minus 0.51 is 0.98. So 98% of people have either a landline or a cell phone. Okay. Which is, well. And D, find the probability that the household had a cell phone only. A cell phone only. So they had no landline, but they had a cell phone. Well, that's that 38 set 0.38. We just have to take that off the table. Good.